Would you go if you got the chance?
I would go if it was for a story.
Really?
Well, I don't know. I think my family might intervene.
On Sunday, the Artemis 1 space mission successfully landed back on Earth.
Splashdown, the latest chapter of NASA's journey to the moon, comes to a close. Orion, back on Earth.
This was a giant leap in NASA's new project to get astronauts back to the moon on a regular basis. No one's been there in 50 years.
We leave as we came, and God willing, as we shall return. With peace and in hope for all mankind. Godspeed the crew of Apollo 17.
Today, the Globe's science reporter, Ivan Semeniuk, is here to talk about the challenges and the cool science of going to the moon, and why the costs and dangers are worth it. I'm Menaka Raman-Wilms, and this is The Decibel from the Globe and Mail. Ivan, thank you so much for being here today.
Well, thank you, Menaka.
So this is very cool. There's a lot of interesting stuff here, Ivan. But why are we going to the moon specifically, right? Like, especially since we've already proven that we can get there and walk around. So why do this?
Yeah, so that's the big question. And I think there are two answers. One is the near term, one is the long term answer. The near term answer is there's definitely science to be done on the moon, so scientists are interested. There are commercial opportunities on the moon, or at least the potential of commercial opportunities on the moon, enough to interest industry. There's also just that sense of you don't want to be left out. If China's going to develop the moon, the U.S. is not going to want to be left out of that picture or cede the moon to others. There's a little bit of that geopolitics going on too. The other longer term question is, as a species, are we ever leaving the planet? Are we ever going beyond Earth? It's a sort of science fiction question, but it's also a real question. What is the long-term future of humanity? Will it involve presence in space beyond our planet? If you answer that question, no, forever we're on Earth and only on Earth, then maybe it doesn't make sense. But if you answer the question, somehow in our long-term destiny and as part of human survival, we need to reach out beyond our world, then these are the initial steps that someone has to take. If people are going to be in space in a more permanent way, the moon is the next step. It's really the next logical step. And now the idea is to return to the moon for NASA and its international partners, which includes Canada, and return in a more permanent way.
And so this program, Artemis, we've just seen the first stage of it, but it's actually in 3 different steps that we've got laid out here. Could you break down the Artemis program for us into these different stages?
Absolutely. It's 3 steps, but with lots of other side steps too, and quite possibly now the budget is there for steps beyond that as well. So more things would be added to this, including a small space station orbiting around the moon, the Lunar Gateway, and various means of getting down onto the surface, but that's still to come. So Artemis is the name of the program.
This is like Apollo. It's like the
It's
Apollo
like Apollo,
program.
right. And so it's the whole package. So Artemis 1 was the test flight, unmanned, uncrewed. And so that's what we've just seen. And during this test flight, it actually went farther than any human-rated vehicle has ever gone. I think it sets the stage now for a first human mission back to the moon, but it won't be to land. It will be to fly around the moon and come back. It'll actually be a shorter mission, just basically to demonstrate the ability of the capsule to transport humans and bring them safely back to Earth, just like that splashdown we saw, which could happen as early as May 2024. The thing that makes that exciting and important for Canada is that even though the crew has not yet been selected, there is going to be a Canadian crew member. That will be followed by Artemis 3, which will actually be a landing onto the surface where you'll have 3 astronauts fly. These will all be American astronauts, I think. Certainly, there will be 2 going down to the surface, and NASA has already said, or the U.S. government has already committed to putting the first woman and the first astronaut of color on the moon's surface. So that's the objective of Artemis 3.
And what year are we talking for that one?
Well, that could be as early as 2025, but again, I think it's going to depend a lot on Artemis 2 and depend a lot on how nimble this program can be, which is a very large program that has already been criticized for being too expensive and sort of NASA doing things the old-fashioned way.
You mentioned a space station potentially orbiting the moon. What's the timeline for that?
The first pieces of the Gateway currently are slated for launch in about 2 years, in late 2024. This is important for Canada because actually that's where Canada's main contribution comes into the picture. For the ticket to ride that we have, sending an astronaut around the moon, Canada is contributing a couple of robot arms, in particular the Canadarm3. People are familiar with the Canadarm2 on the International Space Station. It's the robot that you see on the back of the $5 bill. So this smaller orbiting platform around the moon, called the Lunar Gateway, or now just called the Gateway, is meant as a kind of stopover point. We're used to the Apollo missions where you have a spacecraft that goes directly to the moon, a module lands on the surface, comes back, and then everything comes back, and nothing stays behind. But if you're going to have more regular visits to the moon, the argument is it makes sense to have a kind of platform stopping point where you can have the kind of spacecraft that brings people from Earth to the moon and back, dock, and then you have a different kind of spacecraft like the module that goes down to the surface, and then you can pick and choose where you want to be on the surface. There will be different places that might be of interest. So it's meant to be a kind of stopover point for machines and for people going down to various points on the lunar surface.
I kind of think like the ISS, like the International Space Station, which is, of course, a lot closer to Earth, but we've always got astronauts going up and they're doing different experiments and things kind of like that, but for the moon? For the moon,
but smaller. And, we're talking about 30 meters long, so maybe the size, imagine like a school bus and a half kind of in size, so that's quite a bit smaller than the space station, but also not permanently occupied. I think that's not the expectation. This is why the robot arms become really important. There's this sense that there will be more mechanical autonomy. People can be there when they need to be there, but it's the kind of place that will be running itself a lot of the time.
So the robot arms will be running itself, or we'll be running that from Earth then?
Exactly. I think where we're going to start to really see the big difference, if this program plays out as it's intended, is the way that we may see humans going to work every day on Earth, operating machines or interacting with machines that are operating every day on the moon or around the moon. And I think that, more than anything, is going to normalize this idea of the moon as an area of continuous human activity.
We just passed the 50th anniversary, Ivan, of the last time a human walked on the moon. Why has there been such a big gap between the Apollo missions and now the Artemis missions?
There are a few reasons for that. Apollo was incredibly expensive. If you think Artemis is expensive, in today's dollars, it's remarkable to think this. But at its peak, the Apollo program was drawing about 4.5% of the total U.S. federal budget. That's just an astonishing proportion of expenditure. Once the U.S. won that race, or at least put people on the moon, was first and really the only country so far that's put people on the moon. That budget evaporated. NASA is much more like 0.5% or less of the U.S. budget these days. And also there was this move to commercializing space or using space in a way that was less about, these cowboys out on the frontier versus, making space commonplace, that anyone would go and that you would go every week, that there would be launches all the time. So that's what the space shuttle was designed to do, to make space super accessible. It didn't work out that way. The space shuttle was still expensive, and it proved to be rather dangerous. Two shuttles were lost.
Challenger and Columbia.
Challenger and Columbia. They never got to that vision of having dozens of launches per year. I think it showed that space is never going to be ordinary, but it can be sustainable. And certainly that was the interesting development that we saw in the first part of this century, with the arrival of private companies taking on more of the role of getting into space. And of course, while all this is going on, technology is changing, miniaturizing, becoming more robust, more robotic, more autonomous with artificial intelligence. So the opportunities are growing because there are new tools in the toolkit.
We'll be right back. Let's assume that Artemis is successful. Once we have this more permanent presence, humans or robots, on the moon, around the moon, what would we actually do on the moon?
Well, let's start with science, because that's kind of my favorite part of this. Certainly, if you're a planetary scientist, the moon is heaven. I mean, just think of it. The Earth is an interesting planet, but it's a planet that's changing all the time. It's like a planet that doesn't care about its history, right? Because erosion is wiping away, things that happened on Earth billions of years ago, even millions of years ago. On the moon, that history just accumulates. There's no wind, there's no water in any large way, and volcanic activity is primarily, gone now. So the moon just sits there accumulating history. So you actually can understand a lot about Earth's history by looking at what you find on the moon's surface. And of course, one of the things that's very interesting is over the years, the moon has had water brought to it, probably in the form of comets smashing into the moon, and some of that water vapor then gets trapped in these permanently shadowed craters near the lunar poles. So there could be large reservoirs of ice there. There's a lot of interest in that, partly for scientific reasons, but also because it could sustain people, and also you can turn water into fuel by separating the oxygen and the hydrogen. So it kind of can help sustain space activities as well. So that's why actually Artemis 3, when it lands, is going to be not near the equator like all of the Apollo missions were relatively close to the equator, but right down near that South Polar region.
To learn more about that ice.
Wow. And then there's the entire mineral catalog of the moon itself, and what is the moon made of, including potentially things that could be useful for us.
So commercial opportunities, we're talking about, I guess, mining this stuff?
They're mining the moon, right? So I it's hard to know. It's kind of hard to separate the hype from reality. And I guess it depends to some extent on how difficult it is to mine things on Earth. But I have to, obviously Earth has a lot of minerals and metals that can be mined. Many things, including rare earths and other metals and minerals that we hear about, could be found on the moon. I think the main thing is, at this stage, we don't know the full extent of what's possible. So it's an exploratory gamble in a way, but I think it's a reasonable one. That, the idea is that the more time we spend on the moon and develop the technologies that make it possible to utilize that type of environment, the more opportunities will arise.
Yeah. This is fascinating, Ivan. I guess it makes me think about the feasibility of it all, though, right? Mm-hmm. Because it's pretty difficult for humans to exist on the moon, right? How can we do this?
And it's dangerous, way more dangerous than being in low Earth orbit, much more dangerous than the space station, not only because it's farther, and it is far. Being in the space station is kind of the equivalent of camping in your backyard. So being on the moon would be more like going to a real wilderness area where if something happens, there's no easy escape back to Earth and the attention you would get. So
I think it took Artemis 4 days, right, to get to the moon?
Exactly.
Or to the moon. It took 4 days.
So the moon has the advantage of at least it's at a set distance away from us, and you can plan for that. But it's in a much harder radiation environment. It has another risk, which is just the intense temperatures. If you're in sunlight on the moon, you're in sunlight for 2 weeks. And then if you're in darkness for 2 weeks as the moon kind of goes through its 28-day cycle. And I think the last one that is raised is the dust.
The dust.
The moon dust is scary. It's scary for equipment, and then I think that in turn makes it scary for humans because of how things might go wrong. If you look at the lunar soil through a microscope, you're really looking at, imagine, a multitude of little knives and sharp edges, the things that can gum up the works very easily.
Okay, so we can control things remotely. We have very sophisticated robots now. And we've just established that space travel is incredibly dangerous for people here. So, Ivan, why just not take the risk for humans? Why just take us out of the equation and just use robots to do this stuff in our place?
There's no question that when humans are involved in a space mission, like it or not, it attracts attention in a way that uncrewed missions just don't. And again, it's back to that question of, is space going to be a place for humans? Are humans ever going to leave Earth? Maybe not to live in a colonial way, that, now we're going to make our homes there and start a whole new country or something. But, the way there are humans in Antarctica, for example, or in other extreme locations where it's still of value to have a group of people, doing valuable work, gaining valuable information, and at the same time, kind of exciting and inspiring to see that we can do that. So that's a debate.
We've talked around this a little bit. We've mentioned the price a little bit here, but I want to ask you directly about the cost of all of this. NASA has been given $93 billion from the government until 2025 for this project, the Artemis project. And so I imagine some people might wonder about if this is the best way we can spend this money. What do supporters of this program say against the argument that we should be spending this money elsewhere?
I think the interesting debate in the U.S. was really between, is this a public-led, NASA-led effort? In other words, the U.S. Space Agency, maybe it contracts out who will build the rockets, but it basically operates its own stuff. Or is it going to be more in that model of public-private partnership where, in a more competitive commercial environment, the private sector, kind of carries more of the burden? When this program was laid out 10 years ago, the people holding the purse strings were not completely won over by the private side. Just as an example, there was an interesting question that came up during the press conference after the Artemis mission. The question was really about Elon Musk.
And SpaceX, of course.
SpaceX, of course, right? But, he's making news in other ways, and with the way he's deploying Twitter and so on. And, there is this interesting question, if you're going to hand everything over to actors in the private sector, and that's your national program, what happens if those actors in the private sector become a little bit erratic? So it's. I think the point is that probably a national space program still wants to have some oversight over its brand, and that might be an interesting question for the future. So, but to do that means spending the bucks.
Mm-hmm. Just lastly here, Ivan, if this Artemis program is successful, these three phases that we've talked about, and if trips to the moon become a fairly regular thing, like we've done this, we've established this, is the idea that Mars is next then?
The idea is that Mars is next, but I always feel a bit skeptical about that. I think if the space station is camping in the backyard, and going to the moon is like a serious wilderness camping trip, Mars is like Mount Everest. It is a major, major lift that requires things that we don't have yet in terms of how you would protect people and keep them safe and so on. We'll see how things play out.
Ivan, it was so interesting getting to talk to you here. Thank you so much.
My pleasure. Thanks, Menaka.
That's it for today. I'm Menaka Raman-Wilms. Our producers are Madeline White, Cheryl Sutherland, and Rachel Levy-McLaughlin. David Crosby edits the show. Kasia Mihailovich is our senior producer, and Angela Pacenza is our executive editor. Thanks so much for listening, and I'll talk to you tomorrow.